So we're discussing molecular rearrangement. So first and most important is, what are rearrangement reactions? We all know that organic reactions are classified into 5 different classes broadly. There are many subtypes of organic reactions, but broadly we have 5 different classes of organic reactions. We already have discussed 3 to 4 different classes of reactions. The classification and details we are not going here, but these rearrangement reactions, what are they? We need to understand. So it is a broad class of organic reactions where the carbon skeleton of a molecule is rearranged to give a structural isomer. We can say the intramolecular movement of a substituent from one atom to another. In a simple manner, it can be represented like this. To understand a rearrangement reaction, we need to understand few terminologies. Okay? So considering this example, okay, where we can see a group here or substitution, W is moved from carbon number 1 to carbon number 2 in the product. So we need to understand few terms. First, W is referred as migrating group because it migrates from C1 to C2 in the product. The C1 carbon is called as migration origin, whereas the C2 carbon is known as migration terminus. So the substituent where it started, the carbon is known as migration origin, and in the product where the substituents is end up attaching itself is known as migration terminus. These rearrangement reactions are classified into different types. Okay? The type which we are going to discuss here is migration to electron deficient carbon, or we also say migration to a carbanium ion or carbocation. The first example of this type of rearrangement reaction is Pinacol-Pinacolone rearrangement. Migration to electron deficient carbocation. First reaction is Pinacol-Pinacolone rearrangement. Here I have represented this reaction. Okay. The starting compound is called as Pinacol. By looking at the structure, you can see it is a 1,2 diol, or we also call it as vicinal diol, which is converted or rearranged into a substituted ketone. Okay. So how we can define those Pinacol-Pinacolone rearrangement? A 1,2 vicinal diol or Pinacol is treated with catalytic amount of acid, undergoes dehydration and rearranges to highly substituted ketone known as Pinacolone. The Pinacol-Pinacolone rearrangement we are going to study in 4 different aspects. Okay. First, we are going to understand the mechanism of Pinacol-Pinacolone rearrangement. The reaction takes place in 3 different steps. At first, one of the hydroxy group is protonated and converted to good living group. Okay, we mean water, and the loss of water molecule results in the more stable carbocation. Can be represented in this manner. The first, we have vicinal diol. One of these hydroxy group is protonated. Now this depends on the stability of carbocation which will be forming after the loss of water molecule, and the conversion of this hydroxy into water molecule, that is a better living group, okay, which will be lost in the subsequent step and gives a more stable carbocation. In the next step, the 1,2 shift of one of the group to the tertiary carbocation is assisted by the hydroxy group which gives the protonated ketone. It can be represented like this. The carbocation form in the first step, rather we can say the stable carbocation form after the first step, okay, where one of the R group or one of the group adjacent attached to the adjacent carbon is migrated to that, okay, and this is assisted by the hydroxy group attached to that carbon. This migration results in the formation of a protonated carbocation as shown here. सेकंड स्टेप मध्ये काय होतंय, in the third and the last step, the deprotonation of the protonated ketone takes place and we get final pinacolone as our product. So this is the overall mechanism of Pinacol-Pinacolone rearrangement. Now let's see some of the examples. First case, we have symmetrical pinacoles, which gives the corresponding pinacolone as the product. Here we can see all the substituent on this vicinal diol or 1,2 diol are methyl group. Okay. And after rearrangement, it gives me this tertiary butyl methyl ketone as the product. Here, one of the methyl group is migrated to the stable carbocation, okay, that results in the pinacol formation. This pinacol is symmetrical, so formation of carbocation in the first step to either of these carbon will result into the same product formation. Next example, when we have unsymmetrical pinacoles. Now here we have a different situation or different things need to be considered. For example, if we have 1,2 vicinal diol which has these 4 substituents, okay, these unsymmetrical pinacoles after rearrangement will result into 2 different pathways. So depending upon the pathways they follow, we can say we can write 2 different products. Here, important thing to note that the product formation depends on the stability of the carbocation form in the first step and the migrating group in the second step. So after the careful analysis of this these 2 things, it is observed that only one product, that is this upper ketone or pinacolone, is formed as a product in this reaction, whereas this product not at all formed. I'm repeating. This is an unsymmetrical pinacol. Okay, it can react or rearrange into 2 different ways, and we may predict 2 different pinacolone as the product. This product form depends on the stability of carbocation form in the first step as well as the group migrating in the second step, and because of that only the upper pinacolone or this ketone is formed in this rearrangement. This product which is written below is not at all formed. Next, now when we talk about the unsymmetrical pinacoles, and the different possibilities of the product form, we need to consider the selectivity observed in this Pinacol-Pinacolone rearrangement. So for that, we need to consider few key aspects of this mechanism. First, in the first step, when we talk about the carbocation form, then the stability of that carbocation is very important, okay, which governs or which directed the product form. Second, we need to understand the migratory aptitude of a migrating group. First of all, what is migratory aptitude? It is an ease with which a group migrates during the rearrangement. In other words, we can say how easily a group migrate from migration origin to the migration terminus, here to the carbocation which is formed in the first step. So few key points to remember is aryl groups preferred over alkyl groups. We can say aryl groups migrates easily than alkyl groups. In aryl group also, if we have electron donating groups attached to those, then they migrate easily than the electron withdrawing groups attached to the aryl groups or phenyl rings. A general trend of migration is observed in this manner, where we can say para-anisile is having the highest migratory aptitude when we compare it with paratoluene, which is higher than phenyl, which is higher than tertiary alkyl, than secondary alkyl, than primary alkyl, and least is for the hydrogen. So moving towards the next. Now we are going to discuss the stereochemistry involved in the Pinacol-Pinacolone rearrangement reaction. This rearrangement is completely intramolecular in nature. Now, rearrangement reactions can be classified broadly into two types, intramolecular and intermolecular. The nature of the rearrangement reaction, whether it is intramolecular or intermolecular, can be decided by product analysis. Now, to understand this, we need to study the mechanism. The transition state, which is involving in this Pinacol-Pinacolone rearrangement, has the migrating group attached to both the migration origin as well as migration terminus. So during the rearrangement, it is observed that here we can see with these pictures the migratory group. Say this is your tertiary carbon or an alkyl substituent which is migrating, and in the second picture or second diagram we can see the migration of an aryl group. Here we can see in this transition state the migrating group is attached to both migration origin as well as migration terminus in the transition state. Similarly, in this second case also. Out of these two cases, when we compare, now here we can see when we show migration of an alkyl group, then the carbon is pentavalent. Whereas when we show the migration of an aryl group, then this carbon is tetravalent, which is obviously more stable. So we can say this type of transition state is more stable, where the aryl group migrates rather than migration of alkyl group. And that is why we said that phenyl migrates easily than methyl group in our example. Now to understand this better, we need to take an example where an asymmetric migrating group which is attached, okay, and it has been observed that it shows no change in configuration during the product formation. For example, if we have this asymmetric migrating group, okay, which migrates to this carbocation, okay, in the product, the configuration of this chiral carbon remains unchanged. So, the reaction or this rearrangement is intramolecular in nature. Now, the last point of discussion for the Pinacol-Pinacolone rearrangement is application of this rearrangement reaction. There are various applications. Here we are going to discuss one important application, that is formation of spiroketone. This rearrangement is useful to synthesize pyroketones from cyclic ketone. An example, when we have cyclopentanone, it is reduced in presence of magnesium mercury to give a pinacol, which on rearrangement gives a spiroketone with enlargement of ring. This is an important application of this rearrangement reaction.